deals with kinetics. Kinetics deals with how fast reactions occur. And so, typically we look at the speed of the reaction. Some reactions occur very fast and release a lot of energy, and those reactions are explosive. What we're doing today is a much slower reaction. The reaction we're doing today is on the order of minutes. And then there are some reactions that are extremely slow. And so kinetics looks at these reactions, and we're just going to look at it and just try to map out how fast this particular reaction occurs. And the reaction that we're going to look at is crystal violet chloride. Crystal violet is just given the abbreviation CV. It's a very long formula. It's an organic cation plus sodium hydroxide. And this is going to make crystal violet hydroxide and sodium chloride. As an example of a metathesis reaction, if we look at it in net ionic form, we have the crystal violet cation and the hydroxide anion coming together to form crystal violet hydroxide. And this reaction is easy to monitor the progress of because crystal violet is violet in color, whereas crystal violet hydroxide is colorless. And so as the reaction progresses, the color should fade. When we look at colors of substances, what causes things to be colored? I'm sorry?
When certain color is absorbed.
Yeah, when certain colors are absorbed. So it absorbs a certain color of visible light. And then, excuse me. How can we tell what colors are absorbed? What would we measure? And so this is the field of spectroscopy. Spectroscopy is actually Chem 1A when you start to talk about this. In Chem 1A, when we measure spectroscopy, we're measuring the interaction between light and matter. And when we measure the interaction between light and matter, we generate what's called a spectrum. And there are different types of spectra. Well, let's take a look at the spectrum that we're going to look at today. And so let's look at the crystal violet ion. You know, this has a violet color. Excuse me, it has a violet color because it's absorbing some colors of visible light. Something that doesn't absorb any visible light, do you know what color that is? If something doesn't absorb any colors of visible light, then it's white or colorless. If something absorbs all colors of visible light, then it's black. And so we got to figure out how is the violet color made? And so what we can do is we can take a spectrum of this and then see, you know, what colors are absorbed. But typically, when we're thinking about violet, you know, there are different ways we could have something appear violet in color. One of the ways is, let's take a look at white light. White light consists of all the colors of the rainbow. And so what are the colors of the rainbow? We'll start with red, orange, yellow, green, blue, indigo, and violet. Right, and so if crystal violet did this, if crystal violet absorbed all the colors, except for violet, it allowed violet to pass through, then crystal violet would appear violet. We could easily see this in the what we call the absorption spectrum. In the absorption spectrum, we're looking at, on the y-axis, how much light's absorbed. Absorbance is dimensionless. It doesn't have units, but it does have a number associated with it. Versus, typically we use lambda. Lambda stands for wavelength. And so we're going to go from shorter wavelength to longer wavelength. And so do you know what the visible range, the wavelengths associated with the visible light are?
330 to like 680.
Close. 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 Nanometers, yeah. It's in nanometers, that's correct. 360 is very close. Does anybody know? 360 is still invisible. 360 is what we call, we'll say. Oh, maybe actually 390 to cut off, so it was very close. 390 nanometers. All the way up to 760 nanometers. All right, do you know which of these is red, 390 or 760? 760. 760 is red. Actually, red spans a range of wavelengths, because red is just going to blend into orange. And so at the edge of red is 760, and then 390 is violet. And violet, again, spans a range of wavelengths as well. It blends into indigo. Beyond violet, we call that what? Like ultraviolet. So 340 would be UV. And beyond red here would be called infrared. Those are invisible, but we can also measure those too. And so the spectrum, what would the absorption spectrum of this look like? The absorption spectrum of this, well, we just filled in red, orange, yellow, green, blue, indigo, violet. And so this would be absorbing red, so we expect it to have high absorbance reading. And in fact, absorbs all colors of the rainbow except for violet. And so we have what's called an absorption band, like this. It just absorbs all these colors of light here. This is unlike atoms. When you're taking the spectra of atoms, you get absorption lines. When you take spectra of molecules, you typically get absorption bands, like this. So this is a possibility. Crystal violet might be violet because it's absorbing, all these colors and transmitting violet. But is that the only way something could appear violet? And so this is, the origin. What is the origin of the color? Well, this is one possibility. What's another possibility for the origin of violet color? Another possibility is,
Isn't it red and blue?
right, we could absorb certain of these colors and the remaining colors kind of add up to violet. That would be like, the artist color wheel, they mix colors. Well, we can do the same thing here. You can see how colors mix. So red, orange, yellow, green, blue, and indigo violet will group together because the wavelength range is pretty short for violet and indigo, not so broad. And so red, orange, yellow, green, blue, and sometimes purple is what people call that. But if something absorbs violet, not absorbs, if something appears violet, so that's the color that we observe, it could be because we're absorbing like yellow. If we absorb yellow and remove that out of the color wheel, then the remaining colors will combine to form the average of that, which would be violet here. The spectrum could tell us this, because the spectrum will look different. In this case, the spectrum will look like this. It doesn't absorb here, and then all of a sudden as we get close to yellow, we'll have an absorption band here. Like this. Not a sharp line, but an absorption band. It's because of molecules, the way they vibrate and other stuff. Do this. And so this is our absorption peak. or absorption band for this. And so if we can take out yellow out of this rainbow of colors, then the remaining colors will combine to give us violet light. Or not violet light, but violet appearance, violet color. Or, that might not be it either. Or it could be a combination of colors. If we absorb a combination of colors, then the remaining colors could average out to violet. I mean, we've seen purple light before. For example, the hydrogen lamp spectrum. You guys remember that? The hydrogen lamp, that appeared like almost purple, but that was a combination of red, green, blue, and violet. And those four colors added up to that purple color that you saw with your eye. And so, et cetera. Et cetera would be different combinations of this. And so the first thing we need to do is we just need to see, what is the color, the origin color in crystal violet? All right, so I'm going to stop here because what we're going to do is, today's lab, we're going to do it in parts. And so why don't you check out the equipment, and the first part is we're going to determine the spectrum of crystal violet.